Today, I am here to present a tech talk on the topic Glass Fiber Reinforced Gypsum in Construction. Myself, Sukanya S, Department of Civil Engineering, Vedavyasa Institute of Technology. As we all know, the population of India has been increasing day by day, which again leads to an increase in the housing demand. The cost of building materials is increasing day by day, and the conventional use of cement as well as reinforcement steel has also increased. These constituents also lead to emission of greenhouse gases, thereby we need a sustainable solution. One such sustainable solution is glass fiber reinforced gypsum, which is abbreviated as GFRG. GFRG was originally developed in Australia in the year 1990 and has been used in construction from then. GFRG panels have been used in construction technology in the model of panels which have higher strength and are earthquake resistant and have glass fibers bonded in them along with high density gypsum cement. GFRG is mainly used in construction in countries like India, China, Saudi Arabia and Oman. The constituents of GFRG are phosphogypsum, glass fibers and ammonium carbonate. The purity of various constituents are given in the slide. Also, the figure shows the various constituents, that is phosphogypsum, glass fibers and ammonium carbonate, which are the main ingredients of GFRG. GFRG may be generally classified into three grades, which are water resistant grade, general grade and partition grade. As the name indicates, class 1, that is water resistant grade, are mainly used in places which need to be resistant to water, that is to external walls and in wet areas for preventing the water from entering into the building. The general grade GFRG may be used in dry areas as they are relatively lesser water resistant and they are unsuitable for wall or floor formwork. This is because wall and floor may be subjected to water, and hence if what a general grade of GFRG is used, they may lead to increased water absorption. Partition grade, as the name indicates, are generally used for partitions and they are they have non-structural applications. That is, they are not load bearing, they may be simply used for partitioning. Next, we have a comparison between GFRG and GFRC. GFRG, as I already told you, is glass fiber reinforced gypsum, whereas GFRC stands for glass fiber reinforced concrete. So both of them can be said to be competent to one another. GFRC is mainly used for exterior projects and is mostly similar to concrete in strength because the main constituent is concrete itself. Whereas in GFRG, the main constituent is gypsum and therefore they are light in weight and yet have higher strength. Glass fiber reinforced gypsum has high strength glass fibers which are bonded with gypsum cement to produce panels that were traditionally done with plaster castings. GFRG is much lighter in weight and has superior strength when compared to GFRC and is very much easy to install than traditional plaster castings. They are lighter than traditional gypsum also and can be formed to a better detail than plaster casting. GFRG used in construction. Glass fiber reinforced gypsum is a building material product which is made up of gypsum, plaster and it is reinforced with glass fibers. GFRG, as I already told you, is constructed to a form of panels which are usually constructed to a thickness of 124 mm and a length of 12 meters and height of 3 meters. This consists of cavities that may be unfilled, partially filled or fully filled with reinforced concrete as per the requirement. Many studies have shown that GFRG panels can be used in areas prone to earthquake loads and they may be used as shear walls also. GFRG panels are advantageous in combination with RCC framed column also, and they do not restrict the number of stories and can be used advantageously with RCC beams as well as columns. The figure shows the standard GFRG panel, and as you can see in the figure, it consists of a cavity at the center along with gypsum plaster at the sides, and it is bonded along with the glass fibers which are shown as the various strands. So the total thickness, as I already told you, is 124 mm, which consists of cavity of 94 mm thickness and has gypsum plaster along with glass fibers for a thickness of 15 mm at both the sides. So the general convention is it has a concrete in one of its cavity, and on another cavity insulations may be provided if necessary, and the services, if provided, may be provided in the next duct. So the ducts or the cavities provided may be used for filling concrete if necessary, for providing insulation and for other services. So GFRG panel is mostly manufactured in a factory, and they are used for residential, commercial and industrial buildings. So these are generally 124 mm in thick and consist of hollow core panels and are made with machines and reinforced with glass fibers along with gypsum. The construction of GFRG panels is given in this slide. So the conventional process of construction may be done up to the plinth level. No special foundations may be required for the construction using GFRG panels. Then concrete belt may be provided at the plinth area so as to strengthen the interlocking with the cells of the panel, and then GFRG placed at appropriate positions using machines like cranes, and then the necessary cuttings for doors, windows, sanitary fittings, etc. may be cut out. After this cutting is done, the cavities are filled with concrete and reinforcement as per the strength requirement, and concrete may be filled only in 1/3 cavity of the panel, and the remaining cavities can be filled with various materials also. So the quantity of concrete that may be otherwise required can be significantly reduced by using GFRG panels, and also the waste materials can also be used in an intelligent manner. Finally, waterproofing treatment is carried out for the roofs and floors of the building. So this slide shows the construction process using GFRG. As I told you, the first method, first step is conventional construction up to the plinth level, and then the second one shows the GFRG panels which are erected by using cranes at appropriate positions, and then cuts may be provided for doors and windows. The third step is filling the cavities with reinforcement and concrete if necessary, and also with waste materials. Finally, waterproofing is done so that water may not enter into the building in any case. Comparison of GFRG wall building with conventional building. So the first column shows the materials or items that may be required for construction, and the second column shows the particulars of the GFRG wall building, and the third column shows the conventional building. So for each item, that is cement, steel, sand, granite, metal, water, area and labor required, you can see that the GFRG wall building outweighs the conventional building. The main point to be noted here is that in case of GFRG wall building, the construction time required is just 21 days, whereas for a conventional building, the time required is 120 days, which means that the time can be saved in case of GFRG wall building, and also the labor. Hence, the labor cost can be minimized, which in turn decreases the cost of construction of the total project. So as you can see, the cost of time of construction can be saved by about 82% when compared with the conventional building. Also, for about 1,500 square feet, the construction cost comes around 13.25 lakhs for GFRG wall building, whereas it is 18.27 lakhs for conventional building. Hence, considering cost also, GFRG building outweighs the conventional building, that is the construction cost can be reduced by about 27.47% when compared with the conventional building. So this is the staff quarters that was at IIT Madras, which was constructed using the GFRG panels. The structural engineers in IIT Madras have done much research on this topic, and they have come up with IS codes. IIT professors and research scholars in IIT Madras have been conducting various research on the GFRG panels, and the staff quarters at IIT Madras have been constructed using GFRG panels. The first figure shows the stage of construction, that is after the erection of GFRG panels, and the second figure shows the completed staff quarters at IIT Madras, which was constructed using GFRG panels. So as you can see, there is no much difference between the building constructed using GFRG panels and the conventional building. So most of the staff quarters at IIT Madras has been developed using GFRG panels. So the applications of GFRG is that they are lightweight and may be used in load bearing walls, and they have higher capacity to take up vertical as well as shear loads, and they may be effectively used in earthquake constructions, earthquake prone areas. They may be used as partition infill in multi-story building, and may be also used as horizontal floor or as roof slabs. They may be also used as pitched roofs and as cladding for industrial building, and also may be used as. The advantages of GFRG are as given below. First one is high speed construction. GFRG panels are already manufactured in the factories, hence the time required for construction using GFRG panels has been can decrease by about 30 to 40%. Second is the economy. GFRG decreases the usage of conventional building materials such as cement by almost 50%, steel by 35%, and sand by about 76%. This makes it more affordable and convenient for building construction. Cooler buildings. We know that conventional materials like concrete heats up the building, but GFRG panels can help in making the building cooler by decreasing the temperature by about 4 degrees Celsius when compared to conventional concrete. Increased lifespan. The lifespan of a conventional home is only about 40 to 50 years, but the buildings constructed using GFRG panels can survive or can have a lifespan of about 80 to 90 years. Fire resistance. The fire resistance is because GFRG panels can release 15 to 20% moisture of their own weight, and significantly thus decreases the surface temperature and hence decreases the damage caused due to fire. Earthquake resistance. GFRG panels have been found to be earthquake resistant, and due to this property they are widely used in shear wall construction, which is very important for high-rise buildings as well. Next is durability. Gypsum is known for its durability, and it offers great dimensional stability and strength. GFRG panels have proven to be 5 times stronger and more durable than conventional construction materials. Water resistance. During GFRG panel manufacturing, many types of chemicals are used in the mix, and hence it is water resistant. Lightweight. GFRG weighs nearly 1 kilogram per square foot, which is lighter when compared to the conventional building materials. Hence, the load on the supporting beams and the pillars of the buildings may be significantly reduced while using GFRG panels. The limitations of Gfrg is that it is difficult in stacking and requires careful handling and requires very special tools for cutting and is difficult in delivery. Difficulty in stacking means it needs to be neatly stacked in order to avoid distortion, damage and abrasion. It should be stacked vertically on support extending the full length of the panel. So if this is not done properly, this may lead to damage of GFRG panels and hence may lead to considerable difficulty in construction. GFRG also difficulty in delivery is because they must be carefully handled while loading, transporting and unloading, which for which we need special or skilled labors because they may not be damaged during the transportation. So the figure shows the building which has been successfully constructed in Kerala, and in Kerala a house that has been successfully constructed. So the GFRG panels is a very innovative topic in the current era when compared to conventional concrete and steel construction, and it is supposed that a GFRG will gain its popularity in the coming years. Thank you once again. Thank you one and all.